Right. We got a introduction to OSPF in our previous class. The last topic was forming adjacency with OSPF, which was for OSPF, which has got point-to-point relationship. OSPF, which has got a point-to-point relationship with the other OSPF router. Now, when you say point-to-point relationship, what does it mean? It means that you are connected via a serial link. When you have a serial link connected between two routers, automatically OSPF will say it is a point-to-point network type. How is that possible? The encapsulation on a serial link, this is serial link, point-to-point link. All serial links are called as point-to-point links, WAN links. The default encapsulation type will be HDLC if it is Cisco's router, LC. If it is non-Cisco router, it is going to be PPP, point-to-point protocol. So if any one of this is an encapsulation type, automatically OSPF will say, I got a point-to-point network. When you have point-to-point, there are only two routers, right? In this wire, there is only two routers. Cannot be more than two. See, if it is an Ethernet, you can connect a switch in the middle and you can connect many routers. In a point-to-point, you cannot have more than two. Then there is only two, you and me and you. We need to come to an understanding. That's all. Only two. There is no third person. So if I understand you, you understand me, problem solved. So there was no extra election process to elect a leader. When you need a leader, when you have more people to manage in a group, when there is just two, there is no need for a leader. I should understand you, you should understand me, and problem solved, everything will go smooth. There is no need for a middle guy to manage the group. We don't have a group here, only two. But when there is group, when there is a group, how is it possible to have a group? You need to have an Ethernet wire. With serial, you cannot have a group because there is no switch that can connect serial wires like this. This is an Ethernet technology, LAN. So when you have fast Ethernet or gig Ethernet or Ethernet, we call it as broadcast environment. We call the network type, OSPF network type, as broadcast, not point-to-point, because you got many. Even if you have just two, assume that I don't have this. Assume that I don't have this. Even if you have just two, even if I have just two devices, still it is a broadcast. You know why? The encapsulation type is Ethernet. It's not PPP or HDLC. Okay, whenever we have Ethernet standard as a layer 2 encapsulation, it is broadcast only. Now, whenever you have broadcast as a network type, whenever you have broadcast as a network type, there is need for a leader. Why? To avoid duplication of learning, to avoid duplicate learning, meaning one gives me an update, the same update is given by another guy, another guy, another guy, another guy, it goes on. It's same update, but I'm learning from multiple person. Then I think that this network, the update, the network which is coming in the update is available with this guy, that guy, that guy, that everyone. That's going to be a loop then. There's going to be a loop. So whenever there is a change, we want to update only from one person so that there won't be a duplication, there won't be loop. That one person need to be elected. For that, there is an election process. So only in a broadcast environment, the priority on the interface is considered. In a point-to-point environment, this priority is going to become zero automatically as soon as OSPF finds the encapsulation type as HTLC or PPP. But when OSPF see Ethernet as a standard, the priority on the interface is going to become 1 automatically. Now the router with the higher priority will become a designated router, the leader. The leader to lead the group, the leader to send the update. No one else have got rights to send update to everyone. Only one person has got the rights to talk to everyone, and that is the leader, designated router. He is designated to be a leader. Comparing the priority, they will agree to have a leader. The one with a higher priority only has got the eligibility to become leader. But if you see here, in our case, the priority is a tie. The default priority is 1. We did not set any priority, so the default is taken into consideration. So the routers don't know how to decide based on priority. So it moves to next criteria. If there is a tie in priority, it is going to compare the router IDs. They all send hellos every 5 seconds. Through that hello, this priority, this router ID, the area ID, timer, neighbor list, everything is shared in the hello packet. So now one can know the priority of all other router as well as the router ID of all other router. So every router knows who has got high priority and high router ID. Now let us say we set priority to 10 here, and I'll call this as K, the king. Yep. And then this router has got router ID 1.1.1.1. This router has got the router ID 4.4.4.4. This has got the router ID 3.3.3.3. This has got the router ID 2.2.2. Now, R2, R3, R4. Now, not only K knows that it has got high priority, even router 2 knows that K is the one who is eligible to be a designated router. Every router knows that K is the designated and K is eligible. And K also knows this. But K is very decent. It still wants to know that K is the highest priority router. So K will declare itself as a backup router. Let me designate myself as a backup router. So K will declare itself as a backup router and wait for anyone to say that they also have the eligibility to become a DR, but no one is going to say that. So after 10 seconds, this will declare itself as designated router. It will promote itself as designated router. Immediately, router 4 will say, hey, look at this. If he is a designated router, if K is a designated router, I got the high router ID, though priorities are same with me, like you, 2 and 3, though the priority is same, the router ID of mine is bigger. So, router 4 declares itself as backup designated router, BDR, backup designated router. This election process happens in the X-start state. In the previous class, we learned, yes. First, the routers will compare the priority. If there is a router with high priority, that will become a designated router. And the router with the next highest priority will become a backup designated router. But in our case, there is no next high priority. All other three are having same priority. If there is a tie in the priority, the routers compare the router ID. And the router ID, again, bigger is better. Priority, bigger is the best. Router ID, bigger is the best. So router 4 says I have the biggest router ID. So I get the eligibility to become a backup designated router. So I have a very clear intention in writing this small number here. I just want to show you that it is only the priority that makes DR in this scenario. Even though it has got the low small router ID, it will always take this as its privilege and negotiate, and it becomes DR. Even other router, no need to negotiate here. Even the other routers know that it is K, the one who's supposed to be a DR. So initially they will only compare the priority. Did I answer your question, Sai? Right. So now this all election process happens in the X-start state. The same X-start state we also saw here in point-to-point network. What is the difference? In here, for time being, not forever, for time being intermediate in from the down state to the full state. Down state is the beginning of the adjacency, full state is the end of the adjacency. Once they reach full state, it is done, fully adjacent. So intermediately, in between, they want to decide who is big and who is small, so that they won't have a clash when they exchange the DBD. See, what if two routers try to give the same time? So one should give, another should receive. If two routers try to give at the same time, then no one can receive it, right? So they need to come to a conclusion who will share the DBD first. For that purpose, the one with the bigger router ID, say for example here 22.22.22.22, here 11.11.11.11. So router B will say, I got the privilege to call myself as a master. It declares itself as a master, and this guy will also agree to be a slave. Again, I'm telling you, this is not for the whole OSPF adjacency day time. Only during this adjacency establishment. Whereas this DRBDR and the DR others, this role is going to be forever, even after adjacency formed. This will continue to be a DR. This will continue to be a BDR. This will continue to be a DR other until some re-election happens because of some topology change. But here, this master slave will disappear from the role once they reach full state. When both router form adjacency and reach full state, there is no more master, no more slave. But here, even after having adjacency, even after DR having full state, it will continue to call itself as DR. This will continue to call itself as BDR. This one as DR other. Alright, the role will not disappear. There, in point to point, the role is temporary. It will change. Now, I would like to show you these things in a packet capture. Now, before that, do you have any question? You may ask.
Before in X start stage, the point to point routers one was selected the which router will be master.
In the extart state, which router will be master and which router will be slave? Is that you say? Yeah. The one with the based on the router ID only. Even if you set a high priority, it is of no use. Let me repeat. Even if you set this priority to 100, they are not going to consider priority for master slave election. In point to point, priority will be by default 0. Even if you increase the priority, no use. No use, don't try that. They compare only the router ID. And well, the one with the big number, the bigger router ID becomes the master.
In the broadcast network, before the X start, when it is a two-way stage, in that
No, soon after two-way state. After two-way state. No, 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 no. That is what called as extant state. The place where this election happens, decision making, like who is will be DR and who will be BDR and who all will be DR. This decision making, no, that state, that step is what called as extant state. Before the exchange start, that's the meaning of that. Before the exchange start, we need to have this election. So next state is exchange state. So this is before exchange. The DR-BDR election should happen and get completed so that the exchange will be done as per the policy. What is the policy? Everyone should report the changes to the designated router only. And the designated router only has got the power to distribute those updates to the other. You know, those things will be starting only after the start when the exchange state starts. Exchange. All right. So during this start state, the election process, the roles are determined. Yeah. Correct. Right. Welcome. So now let us move on to the lab and see these things in action. For point to point, we need to use serial link. See, there is also OSPF network type called point to point, which we'll see later. Uh, Even on the Ethernet wire, you can ask OSPF to consider it to be a point to point. We'll discuss on those things later. Now, we got a serial wire. If serial wire is there, the default encapsulation type in Cisco router is HDLC. If that is the case, then OSPF is going to consider this as OSPF network type point to point, which I would like to show first. Later we'll get into that OSPF part. So I'm not going to sniff any packet now. I'm going to simply show you those things that the network type as point to point. Let me quickly use a notepad to finish this configuration. I'll use a template. I'll create a template and paste it on every router, which will save our time. IP OSPF 180. Interface serial 6/0. No shit. IP address 10.12.01. 0. IP OSPF 180. And right to memory. That's all. So this goes on router 1. And now if you go and see here, show IP OSPF interface OSPF. Show IP OSPF interface brief. You can see that this is considered to be a point-to-point network type, and this is a loopback. And you see the priority by default. Sorry, this is not priority. This is called process ID, the one which I gave while I was configuring OSPF here. So if you want to see priority, you should type this command, show IP OSPF neighbor. Unfortunately, we don't have a neighbor because the other router is not ready. But before that, I would like to show you something. Show IP OSPF interface serial 6/0. And if you see here, here also it is showing you that the network type is point to point. Did I configure this? No. Why it is showing as a point to point? Because the encapsulation type, you see, show interface serial 6/0, because the encapsulation type is HDLC. Whenever the encapsulation type is HDLC or OSPF or PPP, whenever the encapsulation type is HDLC or PPP, the network type in OSPF is going to be point to point. And you see the timers, every 10 seconds this interface is going to send a hello packets, and if a neighbor is not sending a hello, it will wait for 40 seconds. After 40 seconds, it will consider the neighbor as dead. On serial link, the default OSPF cost is 64. Now I have shown all that is necessary for you to understand this point-to-point thing. I'm going to sniff the packet now. Start capture between R1 and R2, the serial ports. Right now, okay. So far there is no hello packets going from anywhere to anywhere. I got a filter here just to show hello packets and DBDs. There is no packet so far gone. Let's move. And when I finish configuring an R2, I should see a lot of things, the states. So I'm going to debug first. I want to do both debug as well as the Wireshark. So with both Wireshark and debug, you will learn all that we saw in theory. Let me say debug IP OSPF adjacency. Show me the adjacency states. Not only that, also show me all the OSPF events. Okay, so ADJ is the command. Don't try to type adjacency. There is no command called adjacency. It will understand if you type ADJ. Now, R2. Let me also debug here, though I have not enabled OSPF, IP OSPF, debug IP OSPF adjacency, debug IP OSPF neighbor, debug IP OSPF events. All right. So now let me quickly jump to this one. Do I see any OSPF related packet? Nothing. Do you remember the multicast address that OSPF will use to send the hello packet is 224. What happened? No one knows? What is the multicast address OSPF uses?
It should be
5. Very well said. It is 005. Now, so I don't see any destination packet with 224.0.0.5 nor the source. These are all simply keep alive in a layer 2 level it is going, and not even layer 2 level. It's HDLC encapsulation. It's kind of keep alive that is going between the routers. Now let us bring the other router. I'll use the notepad, same notepad. I'm going to say 22, 22, 22, 22. And here it's going to be 2. See, as soon as I paste, you will see a lot of things going on. As soon as I paste, boom, done. Okay, so we are going to now examine very closely both Wireshark as well as the good Wireshark as well as the debugs. Yeah, wonderful. I see already the neighbor is done. See all the update packets, all packet types I see. So let me stop the debug here. Sorry, the capture here, and we'll come back to this later. Now, going on to the debug, I'll stop the debugs because the events will be keep on coming. All right, now let's start from the beginning. Show IP OSPF neighbor. That's the beginning command to check whether neighbor is up. Of course, the beginning command very well shows that your beginning is very good. You got full state. And look at this, the priority. The default priority is 0. See, if you want to see priority, this is the command that you need to use. Show IP OSPF neighbor. And the neighbor is in full state. meaning fully learned. And now show IP OSPF interface. This is the command which we already saw, but better to use a brief. This will briefly show you in a nice format. It's the same thing, whatever you see here is what you see here. Yeah, the cost. So it's going to be the same thing. Next is you already got one neighbor via this link, which is router 2. We will next verify this debugs. And what I see here is I can see two-way. All right, so this says, hey, I already learned about you. Router 1 is telling, it is communicating to router 2 that I know you, you know me now. We know each other. So that init state is what I'm missing here. Let's see whether we have in the other router debug. See, even here you see the two-way. Both are saying that, hey, now we both know each other. We are friends. Where is the init state? Hellos are sent to 224.0.0.5. Okay. Unfortunately, we couldn't capture that very first init packet. We receive hello from 2222. In that, router 1 is seeing its own address. Router 1 is very happy, saying, hey, I got you, and I saw that you already know me. I'm very happy to see you. And then what happens is this guy says in the exstart state, this is what the exstart state. See, look at this. If exstart state begins, and it says, okay, this is the place where they declare themselves as master and slave. And this says, hey, I compared all these parameters, all the negotiations, and I found that I'm a slave. We are slave in the start state. So when I jump here, this guy is also saying, yeah, what you say is correct. We are not slaves. We are masters. Actually speaking, this router 2 is saying we are not slave, and it is negotiating. And R1 also declared saying, yeah, I got your query, and I also agree that I'm a slave. So immediately this guy declares himself as a master. So this is what happens in the extart state. And after this, the master will send the LSDB in a summarized way, in a brief way. It is sending DBD, database description. Likewise, the slave, also sends the DBD after receiving from the neighbor. Slave follows DBD. I'm sorry, I think I'm wrong. Slave sends it first, and this summary is built. No, the master sends it first, and slave sends later. See, it is receiving here only. So what I said earlier is correct only. So the master sent first. The slave has received it, and now slave sends the DBD. database description. It will be very brief. It won't be detailed LSDP. That is why we call it as database description. Now, what they do in this stage, this is what called as exchange state, where they exchange the DBD, and after the exchange state, they will have some queries, like they will send LSR, links to request, which is what we call it as loading state. Here they start sending the small queries that they got after going through the DBDs that they received. And for the request, you will see the updates also sent back. So here, this is also sending a request. And for that request, this will be sending update LSU. This all will happen in the loading state LSU. LSU is nothing but collection of LSAs. Okay, LSAs, collection of LSAs. So LSU. From there, LSU sent. This is receiving LSU. It's because the request was sent earlier. All right. So this exchange is what called as loading. Once this exchange of LSR and LSU is over, it goes to full state. That is where we conclude that the neighbor is established. Yep. So now let us go to the Wireshark and see this. See, only the hello packets I am showing you. And you see after 22, 26, after 26, 29, 29, 30, 32. So there are some jumps, okay, because I'm showing only the hello packets. All the hello packets, what is the destination address they use? 224.0.0.5. Packet from router 2 is sent to this multi-guest. Packet from router 1. How do I know 1 or 2? Because it's .1.2. Sent to multi-guest. So hello packet, what do they have? Let's see what the hello packet contains. In layer 3 header, you will see protocol field. The protocol field will say it is OSPF packet. It's an IGP protocol. Protocol number is 89. And then if you go down, the destination address is 224.0.0.5. And then again, when you go down in the hello packet, you see the OSPF header. It's version 2 OSPF. It is message type 1. Message type 1. Type 1 is hello packet. The packet length, that means the total OSPF payload is 44 bytes. And this is the router ID. Now you tell me who is sending this? It is router 2 sending this. You can see here also the source is 10.12.02. So it sends the router ID. All right. Now, if you check the neighborship here in OSPF, it is showing, not this one, show IP OSPF neighbor. It is only showing the router ID. It is not showing 10.12.02. Though the interface to which you are communicating and you are receiving the update is 10.12.02, you won't see that interface IP address. It's only the router ID. How it knows? From the hello packet it knows. That's what I'm saying. Though the packet is coming from 10.12.02, the routers don't show 10.12.02 as a neighbor. It shows only the router ID of 10.12.02, which is here. Now the area ID, because we have put area 0, see all 32 bit is 0, and it is clearly showing the Wireshark. It's a very smart tool. Wireshark says, I know OSPF. Who is telling this? Not a Cisco engineer. Wireshark is telling, I know OSPF. According to OSPF standard, If it is area 0, it needs to be backbone. See, all that is there in the back, in the brackets, they're all Wireshark's recommendation. Yeah, very smart, no Wireshark. And there is no authentication. Checksum is for the integrity. Now let's open this field, hello packet field, and look at this. It is advertising the mask. So mask must match with the neighbor. Otherwise neighborship won't come. And then this timer should match with the neighbor. Otherwise the neighborship won't come. All right. And here you don't see any not so stubby area or anything set here. This is capable of redistribution, but we don't have any redistribution so far done. And outer priority, as I told you, this is, sorry, I did not say this one. This is not the interface priority. This is just the router priority. And now the interface priority I showed you earlier, it is priority 0. Let me show you once again. I don't want you to confuse yourself with this priority and the priority here. The priority is always 0. You can see even on the other router. Show IP OSPF interface brief. You see the priority is show IP OSPF neighbor. The priority is 0. Fine, let's go back to this. The daytime is 40-second. See, this is the initial time, it's the first hello packet, so there was no DR or backup designated router. Now let me pick this one, 48, number 48. Now in number 48 also you don't see any DR or BDR, but there is a neighbor, active neighbor, 11, 11, 11, 11. And then this is a packet coming from router 1. It says I have active neighbor. Now let's go back. See, this is packet number 50. Now let me click only the DBD part. See, DBD part, database description, is not after 50. It is inside. It's within that range, So you can see here, even the DBDs are using that same multicast address, 224.0.0.5. All right, now let us see what the LSU or LSR uses. I would like to show you that. All right, so in DBD, what do you see? Let us open, but you cannot see anything. Wireshark is not going to violate the rules. If Wire, all right, so let me quickly have a repeat because the video was passed. We opened all this packet and saw when you do the lab, open all this packet and see what we saw in this class. Now, after the hello packet, after they form neighbor, the DBDs are shared and then the LSR, LSUs are shared. At last, when there is no more LSU and LSRs need to be shared, they reach full state. That is where acknowledgements are sent in between. As soon as the acknowledgements are sent, they are going to full state, loading to full state. Yep. So this is between point-to-point network. There is no point-to-point address seen here, even though the network type is point-to-point. The destination addresses are multicast address, whereas in a broadcast environment where we have Ethernet wires here, we are going to do this after a break. In this environment, you will see some point-to-point, one source, one destination, point-to-point. Not always multicast. Some update packets, request packets will be unicast, right? So we saw how in point-to-point the adjacency happens with a very clear packet capture infos. We are going to do this in between this 4 device, which is connected through a Ethernet switch now. I'll stop this Wireshark, and I'll also stop this to routers. It's not needed. Let me connect Ethernet wire, which is a broadcast. The OSPF will call it as broadcast network type. When you have serial, it calls it as point to point. That comes automatically. You don't need to configure those things.
How many network types we have?
5 network types. We have 5 network types. We'll talk in detail later. We have 5 network types. In Cisco, we have 5. In non-Cisco, only 2. So, as usual, we'll use Notepad to quicken our configuration. On router 3, I'm going to the F33. That will be easy for us to know from where the packets are coming. And on F00, so on F00, as we know, it is between router 3 and 6, so I'll say 36.0.0.3 on the last octet, and OSPF is enabled on that interface. But I would like to keep the interface down so that we can do the debug and see clearly later. First, let us paste this router 3. Next, this is router 4 configuration, and just one number here changed, 4. Select all, copy, and here you go, router 4. And then router 5. 5 here. 5. Now one last router. Okay, so remember, all the interfaces are in down state now. All right. What is next? The next is we need to unshut and see, but before that, I would like to sniff the packet. Anyway, these are all going to communicate. I'm going to sniff here. I know very well this is going to be the DR. Everyone will be reporting to this DR, so I'm just right clicking here. I say start capture so that I can see all the conversations. Or everyone speaks only to DR. All right, you will not have any packet because the interface is down. Let's quickly discuss before we unshut. So this topology, I'll cut a copy of it. Now, The router ID is going to be used for election process. The loopback interface of this is 6.6.6.6. So this is going to be the DR. And this one is 5.5.5.5. And this will be the PDR. Yeah. So the other two routers, they will not reach the X start state. Between these two, 3 and 4, they will be only in two-way state. They won't go to X start state because before they go to X start state, one guy says I'm a BDR, then he promotes himself as DR, and this guy says I'm a BDR. So two guys were not getting chance to become either DR or BDR because their priorities are one everywhere, and the router IDs are smaller comparatively. Yep. So there will be only two-way relationship. They don't get into X start because they understood that already a DR and BDR is available, and we no need to exchange anything. That's the point. We no need to exchange between 4 and 3. There is no need for exchange because this is DR other. We don't have any business to exchange. To avoid duplication of update, we are not going to exchange anything between us. That's what 3 and 4 will decide. So they won't get into X start state. But with router 6, they will go to full state. Even with router 5, they will go to full state. Only between router 3 and 4, 3 will stop in two-way with 4, 4 will stop in two-way with 3. We know what is two-way, knowing each other. That's all. They don't do any exchange. Now, the role of BDR is simply to collect all the DBDs and LSR and LSUs. DBD that BDR received will not be shared with anyone. It will keep it for itself. During the exchange state from router 3 to router 5, DBD comes here. As it goes to DR, a copy is coming to BDR also. So in short, if I need to say, all the updates are sent to DRs. Who are all they? It is both DR and BDR. That is what called as DRs. All the DRs receive update. But BDR is a passive listener. He don't talk. He's a passive listener. He won't talk. Yeah. So it will collect all the information. It will build its database fully synchronized as equal as the DR's database. This both will be alike. But whenever there is a new update from router 3 sent to 5 and 6, 6 will take it and give it to 4. 5 will simply take it. It won't give to anyone. Why? If 2 people gives, then it is going to be duplication in router 4. So to avoid duplication, only DR will talk. Now, how it talks? DR will use this address 224.005 to deliver updates. Okay. Then if it sends any traffic to this address, won't this go to everyone? Of course it will go. That is what the role of DR. DR needs to send everything that it learns to everyone, because this is the address which is listening on every OSPF router, which is in a listening state on every OSPF router. Yes. Now, how can I speak only to DR and BDR? Or how can I speak only to DR? If there is an update here in R3 to be sent to everyone, R3 will send it only to DRs. If it will send to 224.0.0.5, it will go to everyone. Then is there any special address to talk only to DRs? Yes.
006.
Yes. 224.0.0.6. This is the address to which it listens. Who listens? The DR. So we have a special address to talk only to the group called designated routers, which is 6. You see, it is opposite. The DRs will listen to this address and to deliver the updates, it will use this address. So to give 5, to learn it is 6. Whereas the DR others, to get, to listen, it has got .5. To give updates, to give or to deliver update to DRs, it uses 6. See, when you send it to 6, whoever is listening only can receive. Who listens to that address? The DRs are listening. So every router is going to use this multicast address. Again, I'm telling you, it is going to use this multicast address to send the update. They're not going to do unicast. They're going to use this special 6 address to deliver the update. And who only can receive it? Only those who listen. Who listens to this address? It's only the DR and BDR. And only the DR, the authoritative person who can use that 5 to send, not even BDR. DR is the only one which uses 224.0.0.5 to deliver a packet. So whoever takes the role of DR is eligible to use that link 224.0.0.5.
Sorry, can you repeat this again?
Only those routers that are elected, only that router, not those router, only one DR, no, only that router that is elected as DR can use 224.0.0.5 to send traffic. 224.0.0.5.
DRs will use 224.0.0.5 to send the updates to other routers?
Yes. DR will send using 224.0.0.5 because the other routers are listening to .5.
So the updates which learned by DRs, and they will send back to DR others using 005 and not unicast addresses.
No unicast. Unicast is used only when there is a LSR and LSU, which we'll see in the debug.
Okay.
Alright, so we are going to see this in action. I already started the sniffer in between router 3 and the switch. So the Wireshark is already here. And I'm also going to enable debug on router 6 and 5. Router 6, debug IP OSPF events and as well as adjacency. I'll also do that on 5. debug IP OSPF adjacency, debug IP OSPF events. Also, let us enable it on R4. Only on R3, I'm not enabling any debug. Whatever you see in R3, similarly, you'll see in R4 because they're all tier others. Debug IP OSPF adjacency, debug IP OSPF events. Now, what next we need to do is we need to unshut. I'll use a notepad and unshut all the router quickly. Note, we have not configured any priority anywhere. So the default priority 1 is going to be taken. Okay. So here also I would like to show you that already the neighborship established. Oh, I'm sorry, this one. That is the old one. Let me shut that old one. Okay. So now you can see here some of the packets are going to unicast address. Yeah. And most of them are multicast. Now, I would like to show you all those traffics that is going to 224.0.0.6. Meanwhile, I'll go and stop the debugs, which may be too much going now. The neighborship is already established. Now, you see, packet from 5, 6, 4, 5, 4, all these are using 6, which means in our topology, 5, 4, 6, these routers. 5 is using, who is 5? Okay, it's a BDR. It is sending LSU to 6. 5 sending to 6. 6 is a DR. Likewise, 6 is also sending to 224.0.0.6. This would have been in the beginning. In the beginning, there will be like a dilemma: who is DR and who is BDR. That's the time. I'll show you that. And then 4 is sending. That is correct. 4 will send because it's DR other. To 224.0.0.6 whenever there is a update.
So the packet is coming from this IP address to the multicast IP, right? This traffic we consider as a unicast?
No, it is not a unicast. It is multicast. 224 range is multicast. And also, if you see here the layer 2 address, IPv4 MCAST, you see 5E. If you see any MAC address with 5E in the middle, it's multicast. That's 5E is what the 224 in IPv4 address. Now, we see that even though router 6 is a DR, it is sending to an address 224.0.0.6, that is during that intermediate time. But anyone who is a DR only can hear, so no problem. No one is going to listen to this. So this is OSPF packet going from various routers, and this is to the address which DR is listening. See the information that is sent. Here I'm selecting the source, which is 6, from router 6. The information that is shared to DR, sorry, no need to see 6, let us see 4. From 4, okay, this is not an update packet. Here is an update packet. Okay, from 4, what it sends to DR? It says I am 4, I belong to this area, and it sends an update. It is sending a type 1 LSA, which is called router LSA, which we'll see later. It is saying that I got this link ID, which is 44444. This is called link state advertisement, okay? 44444, whose subnet mask is 2455, 255, 255, 255. And the metric on that link is 1 actually. Here, 1. All right, so here it is, the metric. Likewise, there is another network. So these are all the link state informations that goes as an update LSU. LSA, collection of LSA is what LSU. Okay, so that's about update. Now, let's go back to our debug, then we'll come back here. I'll go to debug. On router 6, when I go top, initially it was only receiving hello packets. Go down, you see the two-way here. The hellos on the above is what called as init state, and then they know each other, so it became two-way state. See, hello is received from various places, and while sending the hello, it is sending to 224.0.0.5. Which one? Router 6. Because router 6 for sending it will use 5, even though again it is not going to it don't know that it is going to be a DR this time when you are seeing this line. Okay, now receiving hello. So it receives hello from everyone, and two ways established. Now it is moving on to the xstart state. This is the place where it declares itself as BDR and DR initially. It will say, hey, I'm BDR. And also it will say I'm a DR, waiting for anyone to, checking whether anyone will object. But no one is going to object because this is, no. This says, as of now, I think this is the received one. Router 3 is saying I am DR and I am BDR, but router 3 is not going to be the winner. Why? Router 6 will say later. Okay, these are all conversations still under pipeline. No. I think router 3 has somehow got the role DR. How is that possible? Show IP OSPF neighbor. Router 3 is a DR here. Maybe, the time that R6 was configured is late, or it took some time for the OSPF and R6 to kickstart. So R3 took the role of DR. R6 is BADR now. It is because of the time difference. Yeah, you see, No, not Mr. Wait, I'm coming. I'm explaining. Wait. When R3 is ready, R6 was not ready, and R3 did not hear hello from R6. It was late. It took a long time for R6 to send hello. Even it took long time for R4 and R5 to send hello. So R3, when it declared himself as DR, R6 came. Then R6 have got no other option. R6 cannot hit him down. Once it is declared, is declared. Before it moves to exchange state, it needs the other should come and declare. But once R3 moves from start state to exchange state, no one can stop him from DR. That is what happened. So R6 came little late and took the posting of BDR. Because compared to 6, 5, and 4, R6 have got bigger route ID. So now who is the DR? It is R3. That is why I was not able to see any 3 here. And okay, later I see, but if you go down, even router 6 is sending to that multicast address 224.0.0.6. I was wondering how can it be possible. Then I understood R6 is not a DR. Right, so that's the problem. Time difference. If all the routers start at the same time, no, not physical router, I'm telling about the OSPF process. Only then what we learned will be matching with the output. Now, if you want a fresh restart, what you can do is you can clear OSPF. So I'm going to say clear IP OSPF. You're right. Clear IP OSPF.
So initially, when we start a router, it will automatically become DR.
Yeah. If whoever is ready will become DR. If no competitor, even the small priority router will become a DR. Now I'm going to paste this on R3. Okay, well, before that I want to tell you there is no preemption in OSPF. That is what you saw just now. If R3 has become DR within that period of time, when no one comes and say I'm bigger, I need to be a DR, if no one comes and objects it, R3 declares as DR. Once it is declared, even if a big priority router comes, it cannot. The big priority router cannot force R3. Cannot force R3 to come out from the DR post. That is what called as no preemption. No preemption. Router 3 is non-preemptive. Sorry, DR election, DR posting is non-preemptive. Okay, so I'm going to paste this and let's see. I'll quickly paste it from the first route. First router. Okay, not a problem. That's not a problem. First router, second router, third router. But this need to be done really quick. I'm going again to the first router. So I'm expecting now 6 to be a DR. Looks like 6 is a DR now because I see 6 is sending update to 224.0.0.5. No problem. Now let's go and verify here itself. On R6, I should see show IP OSPF neighbor full. No, still it isn't on the way. Two-way state. Okay, then this debug is, this capture is not still. Okay, now only it's coming. Perfect. Perfect. Acknowledgements are received and almost done. That's it. Okay, neighborship, everything is established. Now I'm going to stop this debug. Now let us see all those traffic that is going to 6 to 24.0.0.6. Now if you see 5 is sending to 6, 4 is sending to 6, and I think 3 don't have any update to send. It didn't send anything. So all are reporting to 6. This don't see on the top. See somewhere in the range between 500 to 600. So we see that everyone is reporting except 3 and 6. All are reporting. So I suspect that 3 might have become BDR. Let's see. Maybe the previous state is still residing, or I don't know. I need to check. Let me go to router 4 and check who is DR and BDR. Show IP OSPF neighbor. Okay, it clearly says still router 3 is the DER. It is because of the bigger router ID. I did not notice. Even last time, router 3 was big. It is not because of time, because of the router ID. Now only I see. Router 3's router ID is bigger than any other router ID. I thought I gave 3333, but I have given 33. Okay. So how many times you restart OSPF? This is what the result you are going to see. Okay, so what I do is I first of all change that. I want to change that. I'll go to router 3 and say interface loopback 0 IP address 3.3.3.3, or you can manually go and say router OSPF 1 router ID 3.3.3.3. Now I have to clear the process on all the router I'm going to clear, and once again we are going to have the capture. Close this capture, start from the beginning, fresh. I'm going to start fresh. I did not notice that router ID. Now, copy, paste it on router. I'm doing twice. Okay. So now, cool. It looks good now. 3 is reporting to 6 now because it's no more a DR. This is what I was expecting long back. It's all because of the router ID. Let's stop this. And okay, now you see 3 is reporting to 6 because 6 is the address to which all the update need to be sent. 4, 5, everyone is reporting to 6. That's good. That's one thing. So let me to DR. Wonderful. So next is I would like to show you some DBDs. If you see DBD here, last time when you saw DBD, it was to multicast status, you remember? But you see here, in a broadcast environment, they want to send the DBD to the neighbors exactly 1 to 1. 3 is sending to 6 and 6 is sending to 3. 3 is sending to 6 and 6 is sending to 3. 4 is sending to 6 and 6 is sending to 4. It's 1 to 1 because they know who their DR is. Alright, but some updates you saw it was sent through multicast, but this is a database description, and even there also you saw some database description. Look at this. Updates, acknowledgements, they're all multicast. Okay, the database description is only to 1 here. Not only that, even the LSR and LSU should be 1 to 1. Let's go and check LS. No, LSR and LSU is multicast. We just saw, but some request you see here. Some request you see, it is going to be unicast. So if you are going to request to a particular, not to everyone, then it's going to be unicast because the DR is the only one authoritative source to provide request, so it's sending us a unicast. So if anyone is asking like whether multicast address will be used or unicast address will be used, you should say both. That is what I'm trying to show you here. You see that LSR is sent to a unicast address. At the same time, when I click on this, here also you have sorry, not LSI. Here you see LSUs are sent to multicast. So LSUs are multicast, LSRs are unicast. LSU is multicast, LSR is unicast, LSU is multicast, acknowledgement is multicast, DBD is unicast. Hello packets are by default multicast only as usual. But unfortunately, you see some hello packets sent as a unicast, but most of them are multicast. This may be because of retransmission. It's a hello packet type 1. With a neighbor, see what all hello packets carry. This is a very good information. Hello packet says the packet length, the router ID, the area ID, if authentication is there, and then subnet mask, timer, the timer, the DR router, the BDR router. But who is DR now? This may be intermediate. Let me see who is DR now. It is 6, no? This is coming from router 6. This is coming from router 6 going to router 3. Router 6 is sending to router 3 saying backup designated router 6. Maybe this is forwarding someone's update. Let me go and check the status. I'll go to router 4 and check now. Show me who is DR. Okay, as usual, what we learned is correct. 6 is the DR, 5 is the BDR. Maybe that is intermediate messages. You need to go down and see the final one. Final hellos going from router 4. If you see this is going from router 3. The election the extract state hellos is what we are looking for. So if you go from down, you will see, yeah. Now you see it has changed the decision. Router 6 is the DR. And then it will say router 6 as BDR also for time being, and then it will change the decision. Okay, so 5 will become the BDR. Now, Any question? I think I have covered all the necessary things that we need for understanding the adjacency state. Any question on OSPF adjacency state in point-to-point as well as in multi-point environment? Anyone has got question? You got two answers. Sai, what you were saying? You said no or yes? You got a question, Sai?
No, Jay, not right now.
Okay.
So, regarding this, database descriptors, sorry, LSAs, LSRs, and LSUs. So, some of them are unicast and some of them are multicast.
It depends on the query from where it comes and type of query. If a query that comes LSR comes, which is common for everyone, then it will be a multicast.
I think the request always come. I mean, when the update
Update is a multicast and request is the unicast.
It's a multicast, and when the reply goes, it's unicast. But sorry, could you repeat?
See, when the request goes, it's a unicast to the DR. And when the response DR send, it will send as a multicast.
Okay.
Yeah, if you rewind the video.
Update, right?
Yeah, update. LSU. Okay. Kindly check the video for avoiding confusion. I showed you in this voice chat. So I don't want to say more and confuse anyone. Kindly rewind and see the video today. So we stop here. Yep. Tell me. Yeah.